Hi, folks. I am so sorry that I can't be with you today, but wanted to make sure that I showed you um, how to use Desmos. We did this problem yesterday, and I showed you the graph, but I didn't show you how I got the graph. And this is what you're going to be doing today with the worksheet that I have for you. And so I wanted to make sure that we were all familiar, at least had something you could go back to take a look. Now, if you remember this problem, Katie, a goalie for Riverside High School soccer team, she needs to get the ball downfield, so she punts it, and it was 2 feet above the ground with initial upward velocity of 40 feet. So we used that yesterday to write the equation h of t equals 2 plus 40t minus 16t squared. And then we talked a little bit about part B, which was when will that ball hit the ground? So that's what I was looking for. And I showed you the graph. We kind of took a look at it real quick. And so what I want to do, what you're going to be doing today, is playing around with these graphs, putting the graphs into Desmos, graphing them, finding them, but you're going to have to manipulate those graphs a little bit to be able to find what it is that you're looking for. So over here in Desmos, so I want to show you, I'm going to come in here and I'm going to delete part of this. So you do h of t equals 2 plus 40t minus 16t. Now, how do you get the squared? Do shift 6 and look how it got up there to that exponent and hit your squared. And then that circle comes at the end again. So if I click on that circle to graph it, that's what I see. See, I see this, I see this, I don't see anything up here. I've got all of this empty space over here, all of this empty space over here. So I want to try to figure out what this graph looks like and kind of manipulate this graph. To answer the question, if you remember, the question was here, use the function rule to estimate the time when the ball will hit the ground. The height of the ball when it's on the ground is 0. This is our time. And so if I go back in here and I add a label that this is time in seconds, then I see that down here. So this will tell me what my x-axis represents. And then up here, I can add a label here. This is my height in feet. So that'll tell me what that is there. So now, at least on Desmos, now I can see and I know what it is that I'm looking at. So when this ball hits the ground is when this is back to, the height is back to 0. So that's at this point. Ooh, look at that. Negative seconds. That's another example of an irrelevant solution. Doesn't make sense in this situation. Negative time in this situation doesn't make sense. So at 2.549, this is what we showed you yesterday. It's an x-intercept. It's when y is 0. That's what I'm looking for. The height, or my y-coordinate, typically is 0. So it's going to take almost 2.55 seconds for the ball to hit the ground if nobody touches it first. But what if I had asked you, when is this ball going to reach its highest peak? You know, when you kick a ball, it goes up, it kind of gets to its highest spot, and then it starts to come back down. Well, where is that? I don't even see that on the graph. Well, the nice thing about Desmos is I can pinch and turn and do all sorts of different things with this graph. And now I can stretch it out, and I can pinch it down again, and I can stretch it out. So I can kind of start to see a little bit. Now, if this gets too cumbersome, I'm like, I just can't figure this out. It's driving me nuts. Go over here to the wrench, and now you can change this. So when I click on this, what I want to do is change that. I'm going to just make it 0. I can always fix it in the graph in a minute. So here, I'm going to change this and make that, let's say 3 seconds. My y-axis, I can start that at 0 also, because I know it's not going to get any higher than that. And if I scroll this down a little bit, I can kind of see, up here, here's my axis, 20, 10, 12, 14, 18. Okay, so 20, these grown by 2s. This is 20 right here. That's 20. So 20, 40, 60, 80, or 22, 24, 26, 27. So it's going to be less than 28. So I might have to go back in and take a look at this again. But if I kind of do this, let's make my Y max 28. And now I can kind of see the whole thing. I kind of got this. I'd like to get out of the way. So when I click on the graph itself, you'll see these points get highlighted. I've got this one down here. I've got this here. This is where she kicked the ball. I've got this one over here, which is where the ball hit the ground again. But up here, I've got this point. So what does this point mean? This point means that I've got, get the right color here. So when I come back over here, I now have, let's go back to here. I don't know if this is going to work. So I'm looking at that. See, I can do that anywhere on here also. So this point up here is 1.2527. So the 27 is how high it is. So the ball has a maximum height of 27 feet. The 1.25 is the time it takes to get there. So from when she kicks that ball 2 feet off the ground to this 1.25 seconds after she kicks the ball, that's when it's going to be at its highest, and then it starts to drop again until it gets over to here to where it hits the ground again. So we call these our critical values. Now, what if I wanted to know when or how many times or something like that this ball was 25 feet above the ground equals 25? See, now I get this handy dandy little blue line up here. And you can see when I click on it that these 2 points show up right here and right here. So if I want to identify that point and that point, come back over here and I can see, all right, that point is almost about 0.9 seconds. It reaches 25 feet. This point right here looks at about 1.6 seconds. It reaches 25 feet. So anytime between that, it's over 25 feet. So that's just another way to kind of take a look at what it is that when you're trying to find a specific height that's not 0, that's a good way to try to do it, is try to get that horizontal line being what you wanted it to equal. So if I now look at, get the cursor again. There we go. I want to take this and I want to change this equation now to plus 96t minus 16t caret squared. Oh my, look, that's all I see. This little part right here, that's all I see. So I know that there's got to be more. So one of the nice things about this is I can scroll out, I can pinch it and find it. So it looks like my other time where it hits the ground. Let's just say I'm shooting a rocket or a pumpkin. I've got this pumpkin 25 feet above the air, 96 feet per second into the air. It's going to hit the ground again in 6.25 seconds. It was shot at 25 feet above the ground. This one, this negative 0.25, irrelevant. Doesn't matter. I don't know what was going on before the pumpkin was shot. But this point up here is going to represent the height. This is the maximum height it gets. In 3 seconds, it is 169 feet high. That's what that point means. So again, watch your X. This axis right here is your time. So this is my 3 seconds. This is my height. So it's 169 feet. So if I wanted to now know, let's say, when is this pumpkin going to reach 80 feet? This line right here, this black, see, I've got black and this is black. It's here and here. So it's going to reach 80 feet at 0.642 seconds, approximately 0.6. You could say 0.64. You don't need to put all of that out. And then 5.36 seconds. So that's what how you would find some of these. So remember your wrench to change your settings. Might be a good idea to put these in. And remember that you can pinch and expand using your fingers on your screen. So I'm about out of time for right now. So I hope this helps, and I will see you guys when I come back tomorrow. Have a great day.